Good morning, Eating Eagles. Kaka! Coming at you this morning on Western Day to provide you with a little walkthrough of the Wordcloud activity. So the Wordcloud activity is a review of everything that you've learned about libraries, file reading, and more. The problem is that we have these very large text files. And we want to be able to let the user pick one of those text files, and we want to do a word cloud analysis of that play to present them with a visual depiction of which words occur most within the play, which might let them see visually some of the importance of some of the words. That's not always true, especially if we don't go through the process to clean the common words. So, like those articles would come out huge, while character names and other things would come out very small. So, as usual, I'm going to start by reading the description and running their solution. So in their solution, we prompt the user with the name of the play. I ask them to enter a number. So they're not going to type the name of the play. The names of the plays are displayed with spaces and correct capitalization. So we enter a number, we press go, and then we get this word cloud, and it looks like there's some randomization of the colors, and the words are changed in size. And we can press space, and it will take them and it will scramble them around. So there appears to be some randomization in the positioning. The size seems to be consistent. So, and the words, the actual words themselves are also consistent. So, it tells us that our input is going to be a number recognizing the play, and then space to generate a new word cloud, a list of plays to choose from, instructions, and the actual word cloud are our three outputs. We must define and call a function. The function needs to return a dictionary of words and the number of times that they appear. Our words should not include any symbols or white space. And then words that are present in this common words should be excluded. So what does that file look like? Okay, so I got a comma separated value that appears to have all the articles and common pronouns. They're all lowercase, which is not true of my poems. So I know I'm going to have to do a little text fix there in addition to removing symbols that don't belong, punctuation marks that don't need to be analyzed. I also need to clean out these words. Then I need to define a function call that actually generates the word cloud. So it's probably going to need that dictionary from the first call. And they should have random color and position, should appear entirely on the screen. So we're going to have to do a little bit of math, or let Python rather do a little bit of math. And we need some kind of function that generates a word size based on their appearance or the number of times that they appear. Allow the user to choose which play to analyze, and allow the user to generate the word cloud by pressing space. Okay, so let's take a look at what they gave us. They've already imported random. They've already imported TSApp for our graphics. There's a threshold here. It talks about that in the thing. If it has to appear more than the threshold, or we're going to ignore it. So they should be, the coder should be able to adjust that as you're playing around. So if you're not getting enough words that show up, you can lower that threshold. There is a tuple that has some predefined color values to choose from. You can use that tuple. We're going to in this, but I can tell you when I created this on my own before the walkthrough, I just did red, green, and blue random values between 0 and 255 and then created my own colors. So I might do that again here just because that was kind of fun. The plays are given to us also in a tuple, but the play names have the spaces in them. If you'll notice, the text file itself is named without any spaces, and then all of them end in .big.txt. So the index that the user chooses from the menu will match the index in this tuple. You're just going to have to replace the spaces. Then we have a symbol library, and I can tell you we're going to add some things to that symbol library as we test this because it doesn't include enough of them. The brackets are there, the parentheses are there, but I think there's a few others. There's some double dashes, and there's some other things that might appear that we want to get rid of as well. So we'll run it a few times and see the output, and then if we need to, we can change that. So our first function is just going to be counting the words. So we're going to define the function called count words. And in order to count the words, what am I going to need? I'm going to need the name of the file that I'm using. So assuming that we get that file name as an input argument, we should be able to then open the file and read the contents. Then it says something about common words here. It says, how will the program know? Open the common and create a list of all the common words. Okay. So since it's comma separated, it's real easy to split that based on the comma. So we'll do a quick with open common words.csv as file. And then we'll make a common words list by using first file.read. So now common words is a string that contains all of the contents of the common words.csv. Then I can use the same variable, common words equals common words dot split based on the comma. So on line 27, comma words is a string. On line 28, we just turned it into a list by calling the split function. So at the end of this section, we now have a list of common words that we can deal with. Now we go into the text cleanup section. Okay, so we did that. Good. So notice I'm using these comments and my hints as checkpoints, so I know I'm getting everything done. How does the text need to be modified? Replace double dashes with spaces. Remove other punctuation symbols from the text. So I need the text of the file, whatever that file name is. So I'm going to say text equals. Now we're getting the file already opened for us here. So this is not, or maybe not. I can let this function do the file opening if I say the file name. Yeah, let's do that. Instead of getting the file object, let's go ahead and open it. So with open, oh, we got to change the file name a little bit because it's not going to be the actual file. We're going to clean it up. So we're going to say file name equals file name dot replace any spaces with nothings. Okay, so we're going to get that input. It's going to be a Midsummer Night's Dream. We're going to get rid of the spaces. And then we're going to concatenate file name plus equals dot big dot txt to the end. Now, with open, file name as file. Okay. Then I want to get all the text out. Say text equals file.read. So I'm going to have it read all the new line characters and everything out of there just as is. Then I'm going to work on replacing some things. So I know symbols, one of the things I can take care of here is I can add that new line character. I'll do that separate because I want to replace it with a space too. Double dashes with space. Other punctuation symbols gone. Okay. So we're done with the file. We're going to come back outside the loop. We're going to let that file close. And then we're going to edit text now. So we're going to say text equals text dot replace. It says replace double dashes with spaces. Then it says remove other punctuation symbols. So I'm not going to replace them with spaces because I'll end up with a lot of extra spaces because the period, the comma, most of those come with spaces after them already. And if they don't come with spaces after them already, like the parentheses, I don't want to insert one that will cause my text to split too many times. So I'll come back in and I'll say for symbol in symbols, text equals text dot replace symbol with nothing. All right, so at the end of that loop, it's gone through, it's replaced the period with nothing, the comma with nothing, etc. Now, if I want to replace the new line and get rid of all those new lines, I can do it here, or I can do it after the split. Either way, I'm going to go ahead and do it here. I'm going to go through the whole text kind of like we did up here. And I'm going to say text equals text dot replace new line. Other way, new line with a space. And that one with a space because new line doesn't have a space after it already. So if I have the end of one sentence, a new line, and then the next line has the beginning of another sentence, it's going to sandwich those two words together, which is also going to make my split not work. So this is about a good time to go ahead and test word count just to see what text contains. I'm going to have it just print text. And then I'm going to come down here and I'm going to call it manually. I'm going to come down all the way to the bottom. And I'm going to pick one of the plays and I'm going to say draw. Oh, it wasn't draw. Count words. Count words. And I'm going to put a file name in there just manually for now. We'll worry about the input in a minute. A Midsummer Night. And notice I'm putting the spaces in there because that's what the menu is going to give it. So I want to test that function too to make sure it's getting rid of that and getting the file name correct. I'm going to say count words, A Midsummer Night's Dream. And I'm going to run it. And you can see there's my poem that's mostly cleaned up. I see it missed a semicolon here for some reason. It missed a semicolon there. So is that semicolon not? Yeah, see there's no semicolon in the symbols list. So let's add that and run it again. So they missed a few symbols, that's okay. There's a whole bunch of blank spaces, but that's okay. When we split those, they'll actually split into each space being a word item, and it'll add more things to our word list, but it's okay because those are not going to meet the length threshold, so it won't make a tremendous impact in our results. Beautiful. Now, right now, I see a lot of capital letters, and we talked about how common words doesn't have any capital letters. So I can come in here and just say text equals text.lower, and then I'm going to run that again. And see, all my capital letters are now gone. So when I do my common word cleanup, I actually need to do that first. So that the common words match. So now I'm ready to do the common word cleanup and use this common word. So we're going to keep that print in there for a minute. Now I need to go through. Common words is going to be shorter than the play. So if I'm looping or I'm choosing a loop, I'm going to choose the shortest thing as the loop controller. So I'm not going to say go through every word in the play and see if it matches. I'm going to say go through every word in common words, because there's a lot less there. It's going to make my algorithm a little more efficient. So I'm going to say for word in common words, text.replace word with nothing. And I'm not going to manually insert a space there because the word should already have a space before it and a space after it. And if I really, really wanted to force that, I really should do a manual concatenation of the spaces on both sides of the word to make sure that it's actually replacing the entire word and not just the letter I inside of every word. So only I when it becomes a word. So that's actually better. So I'm going to keep that. So I'm going to change this now to replace word. And I'm going to put the single space. So I don't need a space before and after anymore because I pulled that word out. So I just need the one space. Now run it. That's better. See, I'm getting a lot less words in there. Do you see I there? I still saw some I's in here. Oh, I bet it's because it's the beginning of the sentence. So we're going to have some issues where some of those get left in. I could run another check for if it just has the space after or just has the space before. So I or something at the end. If I wanted to be fully accurate, I would need to account for the one that doesn't have the space at the beginning, and I would need to account for the one that doesn't have the space at the end, because that's first word of the sentence and last word of the sentence. But that's going to be good enough for this exercise. Okay. All right. So we're not going to print the text anymore. We are done with our cleanup. We have turned everything into lowercase letters. We've read the common words. We've replaced all of the symbols. We've made everything lowercase. We've removed the words. Now our algorithm to count the words is one that we've done before in class. We need a dictionary that's going to store the key is going to be the word and the value is going to be the number of times that it occurs. So we now need to go through every word in text, and we're going to check to see if that word has already been counted. So we're going to say if the first time we see the word, so if word not in word counts dot, that means it's not a key value, because remember, if we don't specify it, automatically defaults to keys. So if the word is not in the word counts, that means we haven't seen it before. So if we haven't seen it before, we just need to add it to the dictionary. To do that, we just use it and assign it a value. So we're going to use the assignment operator to put a 1, indicating that this is the first entry of that word in our dictionary. And then we have an else, means we've seen it before. Then we need to increment that entry in our dictionary. And then it tells us this function needs to return the dictionary. So we're going to, instead of printing here, we're going to return word counts. So that means I need to change my test down here a little bit. Since we're no longer printing inside the function, I need to take care of the printing here. And that's a very odd result. So something's weird here. So what I'm going to do here temporarily as I troubleshoot this, I'm going to print word and make sure it's returning the right things as we're going. Uh-oh. So see, I've got a logic error in my text. My text is being treated letter by letter because text is a single string. I forgot to do one thing before I went into that loop, and I need to split the text. Text equals text.split, and change it from a single string into a list of strings. And I want to just split with the default argument. Now, I'll keep that print in there for just a second to show you the difference. Now we're getting words instead of letters. So my dictionary should be make much more sense now. Before we were doing a letter count instead of a word count. All right, stop. Thank you. Stop. Stop. All right, we're going to stop and we're going to refresh this. Maybe. All right, I don't know what happened there. TextMart had a little hiccup, so I had to close the page and reopen, but we're back. And we're going to take that print out of there. We're going to return the word count. I gave it too much. Okay. There we go. So there's my dictionary, and that's what that looks like after the word count is complete. Midsummer Night's Dream is a big file. There's a lot of words in it. So in our Wordcloud program that we're going to cover in the next video, we'll be actually creating the cloud. We're going to use this dictionary, and things like this fun and palpable gross, those are way less than the threshold, so they're going to get ignored. We're only going to be concerned with things that are greater than that threshold. So you can see there's a lot of words that are going to get cut. Okay, so we're going to go ahead and in that video, we have done the first function, and then we'll come back on part 2 and draw the cloud.